No mai haere mai, tēnā koutou, katoa, talofa lava, malea lehi, ulavanaka and warm Pacific greetings. So good evening everybody, my name is Nick Smith and I'm the Vice-Chancellor here at Te Rangawaka, Victoria University of Wellington. And I'd like to offer a warm welcome to Professor Grimshaw's family and friends and students and her colleagues from the School of Psychological Sciences across the university and to the friends of the university in general. This evening we have the pleasure of hearing from Professor Grimshaw, who is the first professor since the new Faculty of Health Education and Psychological Sciences was created. Before we do, I'd like to say a few words about Professor Grimshaw and her truly impressive array of achievements. Originally from Canada, where she graduated with a PhD from the University of Waterloo, she joined Te Rangawaka in 2007 following a lengthy stint of primarily undergraduate teaching in California. She's just told me that she left California in 2007 because she was unhappy about the direction the politics were going, which almost 20 years later shows her foresight and wisdom. Professor Grimshaw is what we would call a well-rounded academic. I would also call her a Renaissance academic who has made significant achievements through her research, teaching, leadership, and community engagement. She's a leader in a field of cognitive neuroscience with a special interest in the cognitive and neural mechanisms that give rise to emotions. Her drive has been to answer fundamental questions like what emotions are, how brains produce feelings, and how they guide many aspects of thinking and behaviour. Her interrogation of such questions has seen her be recognised as a highly successful researcher of both national and international relevance, reflected in the fact that she's been a principal investigator on the extremely difficult to obtain Marsden grants not just once but twice, has won Research Excellence Awards, and has been a principal investigator at Te Puna Matatini, New Zealand's Centre of Research Excellence in Complex Systems. Her work is highly interdisciplinary, and she regularly collaborates with colleagues from computer science, engineering, linguistics, environmental science, and tourism. As a teacher, she has inspired generations of students with her enthusiasm for the study of the mind and has mentored many honours, masters, and as I understand, 18 PhD students, the majority who are with us tonight, who have gone on to have accomplished careers in academia, government, research, and industry. Notably, in addition to the people who are here tonight, are those who have experienced her teaching, which extends to the high school psychology community where she has served as a minister advisor on the psychology curriculum and has led dozens of outreach activities that have brought hundreds of high school students into the School of Psychological Sciences research labs. Her professorial lecture tonight is titled Thinking with Your Head and Your Heart, Emotions as Core Functions of the Mind. Given her pioneering work in the field, I think there are many ways that could be presented, but I think she's going to present it in person. But there are also deep engagements with technologies like virtual reality, which I'm sure she will refer to. Her talk will trace the shift from a time when cognitive psychologists ignored emotions to the current day in which she and her students have trailblazed the use of virtual reality in lab settings to study the role of emotional states and mental processes. How does the mind work differently when we feel fear, connection, or awe? This work represents a change in the psychological sciences that she has helped identify as part of an affective revolution, an understanding that emotion is a form of thinking, a part of cognition working with other functions like language, memory, and attention that allow humans to achieve goals. Along with all of you, I'm greatly looking forward to this lecture, and please join me in welcoming Professor Grimshaw to the lecture.
Thank you, Vice Chancellor. Welcome to all of you. I just kind of have to bubble a little bit. These first three rows over here are my former postgraduate students, master's students, and PhD students, and it's lovely to see you all here. But also my colleagues from psychological sciences and from across the university, my friends, my family, looking at you. This is a great honor. I have, maybe Nick said, I've been here 19 years. here, and so this is very much my academic home. And it is a very special time for me to be able to talk to you a little bit about what that experience has been like. I'm actually going to even go back before that and talk about some of the earlier days, because those were the early days of the study of emotion. Not way back. I'm not going back to William James. I'm not going way that far. But we've got a couple of decades to cover. Normally at this point, excuse me, I would tell you a little bit more about myself. Oh, there we go. And where I'm from, and from my family and my whānau, and I will, I promise that, in just a few minutes, because what I'm going to try to do is weave together a story of a scientific journey and a personal journey. We'll see how well I do at doing that. But before I begin that, I need to frame the question a little bit. So I started with that title, Thinking with Your Heart and Your Head. And you can just Google this and you get like 1 million pieces of clip art of little hearts and brains talking to each other. This is a really common way for us to talk in our culture about decisions that come from your heart or decisions that come from your head. And often the decisions that come from our heart are thought to be perhaps a little bit impulsive, but more meaningful or something. I'm going to tell you all of your thoughts come from your brain. We know that now, but your heart does have a very important part to play. So I just went and Googled and found a few things, some versions of this myth that are floating around out there, that we have rational thinking and, interestingly, emotional behavior. I'm not exactly sure what the distinction is there. There's not rational behavior, apparently. Or you could have this version. I liked this one. We have the emotional mind, which makes impulsive decisions, but gets to lead a meaningful life. Whereas the rational mind makes calculated choices. I don't know if we'd call those smart choices, but it gets a steady life. Now, I'm kind of thinking which of those I would prefer. But fortunately, I do not need to decide because all of our activity, all of our mental activity is informed by both our emotions and thinking. And by the end of my talk, I'm hoping I will have convinced you that emotion is thinking. But that we'll get there eventually. Okay, so now I promised there would be some more personal about my family and where I come from. So, see, surprise, I should be looking at my notes. I wanted to just give us a little definition, because we use the word emotion very much to mean the feelings that we have, right? So when we talk about feeling, we always talk about feeling emotional. We never talk about feeling vision or feeling a memory. And yet those are experiences too. So I want to just clarify what I mean by an emotion. And not just me, most emotion theorists would agree on this, that emotions consist of subjective experience. That's the feeling part. That's the conscious part of it. But also, there's a whole other component, which is the priming of certain behaviors. So if you find yourself in an emotion, in a situation that evokes, let's say, anger, then you're going to feel the feelings of anger. You might be able to label them even. But your body is going to adopt certain behaviors. You might tense up your muscles in preparation for aggression, even though you're not obligated to follow through on that. So we have control over our behavior, but your emotions help prime you to respond in certain ways. That includes your facial expressions that you might use to indicate your emotions to others, or actions you might take, like avoiding a situation, running away. So those are the behaviors. Those are emotion behaviors. And then we have physiology. So as opposed to something like vision or memory, where we feel it's happening in our head, somehow emotion we feel is happening in our body. And that's because there's a part of your head that is monitoring what's going on in your body. It is sensing that your heart is pounding or that your butterflies are flipping around in your stomach. And so because what your body is doing is preparing itself for a challenge. So this is the key. Emotion is about what you do in a situation where there's a challenge. It could be a good challenge, like pursuing a romantic partner or a chocolate chip cookie, depends on your preferences. But it could also be a dangerous situation, or it could be a defensive situation. So your emotions are priming your body and your behavior to behave in an adaptive kind of way, right? So that's key. Emotions are adaptive. They help us behave in good ways most of the time. All right, now I'm going to talk about my family. These are my parents, George and Margaret. This is their wedding photo in 1948. It was post-war. They're from the north of England, in Lancashire, from a village. My mother's from a village called Ewells Walton. My father is from a village called Eccleston, which is about 1.5 kilometers away from Ewells Walton. Even to this day, my mother's brother has the farm next door to my father's nephew. They swear to me they're not related. But they've known each other their whole lives. In that photo, she's 19, which is astonishing to me. She looks so grown up. My father is 22. My mother left school when she was 14. It was a family decision. She had 4 younger siblings. They lived on a farm. Her job was to take care of the siblings. My father left school when he was 15. That also was a family choice. There was no option for him to go on. He desperately wanted to be an engineer. He was very mathematical. He was kind of hoping the war would last a little bit longer, and so that he could have possibly become a pilot or enlisted in some way that might have let him have that career. Despite that, my parents valued education very highly, and so in 1952, already 2 children, my 2 oldest sisters have been born. They left Lancashire and decided they wanted a better life, and they emigrated to Canada. So they went on ship, as many people whose ancestors may have come here that way. And they arrived, and for the first 11 years that they were there, they were farmers. That was what they were both raised to do. They had a dairy farm. And then eventually that became a really hard financial road to go. And my father took a job as a laborer in a manufacturing plant, and they moved to the big city of Guelph. Anyone know where Guelph is? Yeah, okay. So I was born in Guelph. I'm showing this photo for a couple of reasons. First of all, it's my whole family. So there's my dad and my mom. These are the 2 older sisters who were born in England. That's my brother, and that's me. And I show this, it was one of the only photos I could find that had all 6 of us in it, but also to prove that the 70s really did happen. And also that I'm a baby in our family. So my brother is 10 years older than I am. My sisters are 15 and 16 years older than I am. And they all married and left the house at pretty young ages. So despite the fact that I'm the youngest of 4 children, I kind of grew up as an only child, but surrounded by adults. So we had lots of family arguments at family dinners at which arguments would erupt. And so I learned how to do that at a pretty young age. So I have a very big family. I am also the only member of my family to graduate from high school. My siblings all sort of thought school was not really for them. Almost made it, but went off and did other things. All 3 of them are tremendously successful. And in my family, there's no sense whatsoever that I'm special because I went to university. There's a big lesson in here about all the many ways that you can be happy and successful and lead a very good life. And I'm very proud of all of them. And they're kind of proud of me as well. We're a big sort of mutual admiration society in our family. So growing up as this sort of only child with a father who wished he was an engineer and was really good at math, I became very sciencey oriented. And my parents really sort of nurtured that. I loved going into high school. I loved biology. I loved mechanisms. I loved figuring out how things work. And I became particularly enamored of the brain, even when I was in high school. And I would pester my teachers. At one point when I was in high school, we had a opportunity for students who were not Okay, I was that one who didn't fit in the regular curriculum all that well sometimes. And so I got to go to McMaster University instead of to grade 12 and work in a biochemistry lab and be mentored and do my courses by writing my answers down, things like that. So I was really nurtured in, oh, I shouldn't do that, in pursuing these interests. My father once, this is how I know how much he loves me, I read something online that said that about dissecting a cow's eye. It was a thing the San Francisco Science Museum put out. And so my mother went to the butcher and asked the butcher for a cow's head. Had to put it in order and wait to be able to get it, but home came the cow's head. And then I'm like, oh, that's exciting. But then it was like, well, it looked like a cow, which I was not expecting. So that was a little bit distressing. But my father, bless his heart, because the skull of a cow is fairly solid. You don't like just crack it open. And so we had to go out to the garage, and he got out his power tools, and he's hacking away at this. So we pretty much destroyed the brain in the process of doing it. But at that point, I was hooked. All right? And so finally, I got to go to university. I went to the University of Toronto. This is Trinity College. So being the first in my family to go to university, I picked the most pompous one I could find. We wore academic gowns to dinner every day. It looks a lot like Hogwarts when you're actually inside. It has a divinity school, so that it's not religious, but we did say grace in Latin. I can still say grace in Latin today before dinner. We sat down family style to eat dinner. It was a very strange world. But it was a wonderful world, and I really enjoyed being in the university environment for about 6 months. And then I discovered all these things I had missed during high school, like dating and parties and things that were way, way, way more fun. So what I will tell you is the end of that story is that I finished my undergraduate degree in biochemistry. By the way, I never took a psychology course. Finished my undergraduate degree in biochemistry with a C+ average. Anyone else in here have a C+ average from your undergraduate degree? Thank you, Bart Ellenbrook. All right. However, I know exactly why I ended up with a C+ average, and it's this man right here. That was 1985. I took the date off the camera. It's 1985, so that is 41 years ago. And it is the day he asked me to be his girlfriend. I look 12. I mean, really horrifying. But hopefully that means I age well or something like that. It has been the most incredible journey, and I won't get waxed too rhapsodic about it, but he's a really good guy. All right, so I kept him. And I graduated with a C+ average. So what do you do when you graduate with a C+ average in biochemistry and your whole life's ambition was to be a physician? Because that's what I wanted to be, because that's what people who are good at biology do. So I couldn't, it's a postgraduate degree in Canada. I couldn't get in to any postgraduate program. I thought, oh, maybe I could be a science teacher. I couldn't get into a teacher training program. So like, oh, what am I gonna do? Turns out you can move to Northern Ontario and be a youth counselor. And so that is what I did. I moved to a town called Elliott Lake. Anyone know where Elliott Lake is? Lou knows where it is. If you're in Toronto, you drive 5 hours north till you get to Sudbury, and then you turn left and you go another ways. Okay? And when I was there, despite the fact that I had never taken a psychology course and had no counseling experience, they hired me as a youth counselor because I'm nice. And because I actually had a summer job before that as an assistant youth counselor. And so I worked for the YMCA in a youth vocational program. I became a certified life skills coach. I am still a life skills coach. If anyone needs help, let me know with your life skills. And so my role was a program was working with adolescents who were not working well in the high school system. So starting at the age of 15, and they were not in school either for reasons of correctional, so running into problems with the law, or with school, or with mental health disorders. And that was when I started as part of that team. I was not really counseling. My job was to help them into gainful employment and be a counselor to help them do this as a way of something that was an alternative to school where they could experience some success. So that was the type of counseling I was doing. My clinical colleagues, do not panic. They didn't let me do anything resembling therapy. But that was the first time I actually met psychologists. And I discovered real interest, particularly working with the clinicians from the mental health unit, where they had adolescents who were coming out of residential care and coming back into community. And I started to learn a lot of things about psychosis and about the mind and various types of psychotic disorders. And I thought, that's really cool. It's not. It's tragic. It's a terrible thing. And I'm so glad that there are people who want to work in service of helping those people. On the other hand, the brain thing, really cool. And so what I had discovered by doing this was that I discovered my passion for both science and people. So it turned out I was actually not good at biochemistry because it's boring. Sorry. Sorry, Bart. Because it's about cells, and it's about chemicals, and it's about Krebs cycles. I wanted science, but I wanted science that was about people. And that is when I discovered that psychology actually was a science. My entire undergraduate Bachelor of Science degree, nobody told me. And so I took my very first psychology course by correspondence. In 1988, correspondence means, and I lived in Elliott Lake, it means that I got cassette tapes in the mail every week. They were Phil Miracle doing lectures from the University of Waterloo distance education program, and I would listen to the lectures and I would read the textbook, and then I would do my assignments and I would put them in the mail and I would mail them back. That's how I learned intro psych. And then eventually I was like, oh, I actually kind of really like this. And I want to do this as a career. So I went back to Toronto. I did what you would all here call a grad dip. I just took psychology courses for 2 years. I volunteered in a lab, a behavioral endocrinology lab at the Hospital for Sick Children. I took a lot of courses so I could get good grades and prove that I really do deserve to be in postgraduate training. Also, I wanted to show you. This is why I didn't stay in Elliott Lake all that long. I was going to say, it's really pretty in the summer. That's what it looks like in the winter. So I went back, did my 2 years of study at the University of Toronto, and then I begged my way in to the University of Waterloo, quite literally. I went to visit this man. Oh, wait, no, there's a life lesson. My story is going to have life lessons all woven through it. This one, you have never messed up so badly that you can't undo it. I tell this one to my children all the time when they think they have ruined their lives. You just have to fix it. It might take some time. It might take some effort. You just have to fix it. We're going back to the history part now. So I now arrive at the University of Waterloo, wanting to understand everything there is to understand about the brain. Turns out other people had done this before I got there. I wasn't the first to have this idea. So I am now going to give you a crash course in the history of the study of emotion. We're going to begin with, I'm looking at Simon. I know philosophy did this ages and ages. Okay, we're now on to people who did experiments, sort of. Wilhelm Wundt, often credited with being the first psychology, setting up the first psychology lab. We call him a structuralist, wanted to figure out what is the stuff of mind. This view was challenged by William James, a philosopher, who wrote what is the first, some would still say the best, psychology textbook, The Principles of Psychology, in which he takes a very functionalist view. He talks about what minds are for. Minds are for remembering. Minds are for making decisions. Minds are for seeing. Minds are for feeling. he very clearly put emotion as one of the functions of mind. And in fact, he produced what is the first neurological theory of emotion, that emotion is just your brain sensing what your body is doing automatically. So when you are afraid, your body responds automatically to the threat in your environment, and then your brain notices, the part that senses your body, that your heart is pounding. And so the phrase that we use to describe James is, I do not run because I am afraid because I run. This is a theory that has roots that are still very much part of emotion theory today. But then a few spats happened between the functionalists and the structuralists, partly because nobody had any data. And so it all felt like a lot of speculation. So along come a couple of behaviorists to save the day. I'm looking at Dave. The first one is John Watson, and the second is B.F. Skinner. And they're I'm just putting them up there to stand for a whole movement that said, if psychology wants to be treated seriously, we actually have to have data. We actually have to be able to produce something that's predictable. And so they argue we should focus on the things that are in the environment that are the input coming into the system, and the behaviors going out of the system. You can measure both those things, and you can get the relationship between them, right? But we don't know what's going on in the middle. It's a black box. So let us not speculate about what's going on in the black box. And so things like memory and perception and decisions and things like that were sort of banished for a while from psychology, and emotions went with it. And then we have, starting in the 1950s, these aren't even psychologists. The bottom one is a very young Noam Chomsky, presumably before he met Jeffrey Epstein. And the one on the top is Alan Newell. So Chomsky is a linguist, and Newell is one of the early computer scientists. And so from outside psychology, people started to be thinking about what's going on inside the black box, started to be able to program things that could act like minds. And so these provided the impetus for the study of the black box to happen again, to say, yep, we could actually start, there are ways we could figure out, instead of just guessing, what's going on in there. And that's what we now call the cognitive revolution. So probably bits and pieces of it you see in the 50s, kind of became strong in the 60s, and pretty much was dominant in the 70s. And still today is a pretty dominant perspective in a lot of areas of psychology. They were really inspired by engineers. And so what they did was they started making models that look an awful lot like engineering diagrams of information processing. The idea is, this is the revolutionary idea. Brains are information processors. That's what they do, right? Your liver processes toxins, your digestive system absorbs nutrients, your brain processes information, takes stuff in, does some magic with it, and then guides your behavior coming out again. But in the process, you can now start to model this on a computer. And so you get these things that look very computer-ish. And so a lot of things that we would call thinking became the domains of cognitive psychology. So attention, so every single cognitive psychology textbook of the time, even now mostly, has the same chapters: perception, attention, a few memory chapters, knowledge, language, reasoning, decision-making, problem-solving. That's what you get. Thinking, things that a computer could do. So being inspired by this model, you can see emotion doesn't get to come, because we're still tied to this idea that emotions are all about feelings. The feeling is part of the emotion, but the experience is part of memory and attention and language as well. But because emotion feels so human to us and so deeply different than thinking, it was left out of cognitive psychology as well. So that's I love this quote. So this is B.F. Skinner's reason for getting rid of the emotions. To be fair, this is actually a line that he wrote a novel called Walden 2, which is about a utopian society based entirely, if we all lived according to behaviorist principles, the world would be so amazing. And there was no need for negative emotions. Apparently positive emotions got to stay, but this character was explaining we don't need negative emotions anymore, and besides, they're just bad for you. So how great is our society that we don't have negative emotions anymore? Okay. So that sets the stage for me arriving at the University of Waterloo to do my PhD. And this man was my mentor, Phil Bryden. Phil Bryden did his PhD in the late 50s, early 60s. He worked with someone named Donald Hebb at McGill. Very much of the people that were starting to think about minds and brains being something that was actually knowable. We could actually start to develop some theories about these things. He was a fantastic mentor. He changed my life. He didn't do very much. He would wander into my office. I had an office. I was there every day, just saying. And he would go for a stroll every afternoon. Keep in mind, no one has internet, so you can't work anywhere but your office anyway. And he would stroll into my office, and he would sit down and say, I've been reading this. And then he would just drop it on my desk. And then he would leave. I'd be like, I think I'm supposed to read that. So we had a lot of very good conversations. We didn't have very supervisory meetings. So this is life lesson number 2, which is find good mentors. I have been so blessed in my life with the number and the quality of the mentors that I have had. I find them so well, and I flock to them. So a good mentor is life-changing. So what I wanted to study when I was up there in Elliott Lake thinking about minds, I became fascinated, having read some things, about this idea that we have a left brain and a right brain. We don't really have a left brain and a right brain. You have a brain. It has 2 hemispheres, one on the left and one on the right. But there's this really popular notion in popular culture that your left brain, this is actually a Mercedes-Benz ad, but it's such a great diagram. I can't read it all, but the one on the left is, I am the left brain, I am a scientist, a mathematician, I am practical, I am order, I am logic. It seems to be the one who gets the steady life, I think, from our other model. The right brain, I'm not allowed to walk past here. The right brain, I am creativity, I have free spirit, I am passion. It goes on and on and on. Of course, we all want to be the right brain, except that our society, chooses the left brain. So hogwash is all I can say about that. You have 2 hemispheres of your brain for a reason. You need them both. You cannot tie your shoes without 2 hemispheres in your brain. So they work together continuously to do things. But it is true that they do different things. So we have known since 1861 that an area in the left frontal lobe is really, really important for language. So this is a brain, belonged to a man, his name is not Tom, but that is his neuropsychology name. And he was studied by Pierre Broca in the 1860s, who was a neurologist who noticed that Tom lost the ability to speak as a result of a stroke that kind of took out a big chunk of his left frontal cortex. But he could still walk around and he could still do lots of things of his job. And so it didn't damage everything, it just damaged language processing. And so then Broca did a bunch of other studies and found this pattern recurring that damage in this area of the brain affected language, but not other things. And patients with damage in other places had different problems, but not language. So this is the beginning of the localization movement, I guess you would say, that different parts of the brain do different things. So In the lab that I went to, we did research on the left and the right, the contributions of the left and the right side of the brain. And it being 1987 when I got there, nobody had a scanner. So we did very, very old-fashioned, old-tech brain imaging. And you do it with a set of headphones. So this is a technique called dichotic listening. It's been used in psychology for eons to study attention. And what happens is you put something on, you put a set of headphones on, and you put one message in the left ear and one message in the right ear. And you speak at the same time. So you've got these conflicting messages coming in, and your job is to either report back or listen for a particular word or something like that. Now, the way your ears are connected to your brain, the right ear is strongly connected to the left auditory cortex. The left ear is strongly connected to the right auditory cortex, which in normal hearing is not a problem at all because you have two ears, and when sound comes in, it goes in both ears. But when you've got competition, you've got headphones on, now each ear, so each hemisphere is getting a different message. So you can say which hemisphere is better at listening to these words. So you might hear tower in one ear and power in the other ear, and it all just sounds like one word because your brain likes there to just be one reality that it has to deal with. And you tend to, interestingly, hear the one in the right ear. Really reliable effect. It's been replicated. People talk about replication crisis in psychology. This is a very robust effect. And yet you're better at detecting that speech in the right ear than the left ear because the right ear is connected to the left hemisphere, and the left hemisphere is the language processing system. Who needs a $3 million fMRI, right? So what I was doing in my experiments was playing around with the tone of voice that those words were spoken in. Because there was some suggestion that while this part of language, knowing what the word was lateralized to the left hemisphere, the right hemisphere seems to be involved in processing things about tone of voice. So now what you can do is you can make those words in an emotional voice. So you can say tower or power or something like that. It's not my voice, thankfully. We have actors who do this for us. And now you tell people, don't worry about what the word is. I want you to just listen and tell me what the tone of voice is. Now, people are better at the one in the left ear. Same words. So if you ask people to listen to what the word is, they're better on the right ear. If you ask them to listen to the same thing, but listen to the tone of voice, they're better on the left ear. And this is your left hemisphere and your right hemisphere working together. And real language, not lab language, real language always has tone of voice attached to it. And so what the cognitive psychologists have been doing is trying to look at just speech in isolation, but missing the point that real speech never occurs without a voice attached to it. And there are not individual words. There's always some emotion attached to those. So where do I go? So that was my research was working out when do we hear one, when do we hear the other, and how do you, in the end up with some sort of integration of the two. Keep in mind, you're not allowed to study emotion in cognitive psychology. I was in a cognition and perception program. And so, in fact, this is a publication that came out of my PhD. You will notice the word emotion does not appear anywhere in the title. Integration and interference in the cerebral hemispheres. We just took it as being, this is the study of your two hemispheres talking to each other. It's not a study of emotion. Did another study a couple of years later, after I'd moved to my next position. Again, we've got same phenomenon, but now what we're starting to find is not only is the right hemisphere processing the emotion of the word, that if the word is spoken in the emotional tone of voice, the right hemisphere starts to be better at processing the word as well. So if I now say, pay attention to the word, your right hemisphere is actually, if it's emotional speech, is much more engaged than it would be normally. But again, you will notice the word emotion does not appear. It is not until 2016 when Hazel Godfrey and I did this study again that we finally replicated and extended the effect that we said, you know what, we're just going to call it emotion now. So this was the zeitgeist starting to slowly be able to creep some emotion in. But in general, we called it prosody, so information carried in the tone of voice, or you would call it facial expressions if you were doing facial expressions, but we would not call it emotion. You knew there had to be baby pictures at some point. So many people think that producing a PhD thesis, I'm looking at some of you over here, is a bit like having a child. I will say no, it's not. But while I was doing my PhD, I tried that twice. So on the right we have Laurel, and on the left we have Emma. So they were the other production of, they were our production of our PhD. This is Laurel's graduation from university daycare. And they have little gowns and caps that they wear. It's so amazing. All right, so my kids have always been part of the university environment. I dragged them along to the lab. They slept in the lab. They have always been part, and my students know this as well. They've always been part of this whole journey. They're adults now, just saying. Okay, finally, I finished my PhD, and I was awarded a fellowship by the Canadian government, something called the National Science and Engineering Research Council, and it allowed me to basically go anywhere I wanted in the world for 2 years and would pay my salary and some travel, and I wanted to go to New Zealand so badly. My PhD supervisor had a colleague, Mike Corbelis, many people know Mike, at the University of Auckland. He was my PhD thesis examiner. And so it would have been a fantastic opportunity for me to come to New Zealand. But at the time, both of our mothers were unwell, and we thought it was too far to move to the other side of the world with 2 young children. And so we moved to California instead. I took up my fellowship at the University of California, San Diego. And this is where we learn life lesson number 3, live near an ocean. And we live in a country where that's so easy to do. But for me, it's a thing that I still, every day when I walk to work and I look at that spot on Glasgow, when you look out and you can see the harbor, I still catch my breath when I see it. I did my postdoc at the University of California, San Diego, in cognitive science. So UCSD had one of the first cognitive science departments in the world. It was formed in the 1980s, cognitive science brings together psychologists and computer scientists and developmentalists and linguists and philosophers, and it was a wonderful place to be. You could go to a talk all day, every day. So you didn't actually have to spend any time in your lab. You could just wander around and soak up the ambiance of people talking about minds everywhere. Turned out to be a pretty short-lived postdoc, though, because we decided we liked California, and I got a job as an assistant professor at California State University, San Marcos. So this is when Nick alluded to my primarily undergraduate teaching role. When I started at Cal State San Marcos, was 5 years old. It was a brand new university. That building there is the only one that was there then. It now has 15,000 students, very, very strong STEM program. It was a wonderful place to work. Academics in the room, I taught 3 and 3. So I taught 3 undergraduate courses in each semester, no teaching assistants, no postgraduate students. So it's a teaching job. But it was a really wonderful teaching job. It's a really wonderful university. It's classified in the US as what they call a minority serving institution. At the time, about 48% of the students were Hispanic or Latino. Even still, I just checked the graduating class, more than 50% of the students are the first in their family to go to university. So it was a really, really it was a great environment in which to learn to be a teacher, to learn to be a mentor, to learn about the impact that education can have on people's lives. This is my first lab. They're all undergraduates, so I still set up a lab. I had one computer testing space, and I am still in touch with most of those students. 3 of them are academics, and they were a wonderful, wonderful team. And this is where I learned life lesson number 4. I've possibly lost track, which is not just get a mentor, but be a mentor. I used to say be a good mentor, but you can't. You have to learn somehow. So I cut my teeth on them before I got here. Mentoring is the most powerful way to learn something. And it is through the act of mentoring my students that I have learned so many things about psychology, but also just things about being human. So it's a really, really wonderful thing, and you are never too young to start. So in my lab, we have always had an older sibling, younger sibling type of relationship. Older students, more senior students are meant to mentor more junior students, and they know how that goes. Finally, 7 years later, I get to go on sabbatical, and I finally get to go to New Zealand. So our whole family packed up. We came for a sabbatical at the University of Auckland. We lived on Waiheke Island. And I thought, oh, New Zealand is amazing. It was fantastic. I took the ferry into the university. Our kids went to school barefoot. It was absolutely fantastic. At the end of sabbatical, they make you go back. You have to sign your mortgage, like your house, away when you leave. They said, okay, you have to come back. So we came back. But then we said, why do we live here, really? I cannot remember why we live here. And as Nick also alluded, we were becoming more and more disillusioned with the friendlier version of US American politics. And so we up and started looking for jobs, and we moved here. We decided on Wellington from the get-go. I could have lived on Waiheke, really, but the whole commute to the university and everything like that. So I still love to visit Waiheke. And here we have life lesson number 5, which is sometimes you just have to start over. So when I came here, I gave up a tenured associate professor position. I became a lecturer because that's what Dave was hiring. And I really wanted a job. And to be honest, I hadn't done much research. I had done some, but not much, because of the whole teaching thing. And so Dave, to his credit, hired me. I still don't know why. On paper, it looked terrible. And it's been the most amazing experience. I've had so much support, so many opportunities, met so many great colleagues, had so many wonderful students. I am a VUW fan, but I had to really kind of I had to go back to baby steps and build a lab and remember what it was like to do experiments as a big part of your job. After a while, we started doing EEG research, so expanding on our behavioral research that we were doing. This is it was very clean at one point. EEG lab that is up on the 6th floor. I thank my previous heads of school who helped make that happen. And it's now a really bustling EEG lab facility. And so this became the great place, a really, really wonderful place. I had this great supply of students, and I had really good colleagues. So speaking of which, David Carmel. David and I have been colleagues actually from before the time he came here. I won't go into that story now. But we applied for a grant from Marsden, as Nick alluded, to do this project controlling emotional distraction, testing. We had a particular model of how we thought the brain would do this. So here's the problem. So a lot of people have talked about the fact that emotional things grab our attention, right? You've all heard this. People talk about, when there's an accident on the highway, everyone slows down to look. And it's as if somehow you have no control over that. It's this automatic thing that just jumps out at you and scares you, or jumps out at you and you must eat the cookie right now, or whatever it is that emotional stimulus is. But that seems not to make that much sense to me, because emotional things are everywhere, right? There we go, life lesson 6, find good collaborators. I'm so lucky with mine. But here's the problem. So, right, as we walk around the world, there are I'm leaving that up for a little while. There are emotional things everywhere. If we were at the mercy of these emotional stimuli, how would we ever get anything done, right? So I might be anxious about how you're perceiving my talk, and I could be looking at all of your facial expressions to judge, but that would defeat the purpose of me actually giving my talk, right? So I just need to let go of that and control my emotional response to those things. So can people do that, and how do people do that? So together we modified a paradigm that cognitive psychologists have been using for a long time. So just to wake everyone up, we are going to play along with the game here. A letter is going to appear that's either an N or a K. And when you see the N or the K, you're going to say out loud whether it's an N or a K, right? Okay. And then you'll have all been in a cognitive psychology experiment, and you will know why students do not want to be in cognitive psychology experiments. Okay, here we go. K. Okay, well done. I heard some giggles. Which means that you noticed that sometimes there was something else on the screen, right? So the things that we're putting up on the screen were either negative images, we use mutilations, nobody really likes those, or positive images, we use various types of erotica, depending on what study we're doing. And then just for neutral, we've got people in the neutral picture, but they're not doing anything particularly exciting. And what we're wanting to see is how much does it slow you down when those emotional things are there, right? Because so if emotional things grab your attention, then you should slow down, and like you all were. If I had been clocking you, you would have all slowed down on the images when those images were presented. And we're going to have another version because we like controls. Maybe it's just the color red that you're attracted to, not the blood. So we're going to make scrambled versions of all of those images. This is the only data slide in my talk. I promised Todd Jones that there would be data. So what we're going to measure here, to walk everybody through, we have on the y-axis is distraction. How much does it slow you down? So the higher the bar is, the more it slows you down. And what we have, the orange bar is negative images, the yellow bar is neutral images, and the green bar is positive images. Really big effect. It's about 50 milliseconds, which doesn't seem like a lot of time, but trust me, it is. That's about how big the Stroop effect is. So but the question is, what happens with the scrambles? Maybe the scrambles are also distracting. Nope. So it's because of the emotional content of those images. So now I've kind of just said, oh, emotional things do attract your attention. But do they always? So what we did was we went on a campaign to figure out what are the conditions in which emotional things attract your attention, and what are the conditions under which you can make that stop. So I'll just give you the quick version, which is a ton of work done by those people over there, found that, in fact, you're not a slave to those emotional images. If we reward you for paying attention to the N and the K, you do better. So perhaps what you've got is more of a flexible system, right? If those things have some value to you, you might attend to them, but if they're not, you don't have to. You can control. I forgot, sorry, Hazel's got a study up there as well. So that was a ton of work that went into that. I'm going to wrap up in about 10 minutes. I'm skipping this. This is just saying, this is now, all of a sudden, emotion is everywhere. That's what this graph is showing. This is how often studies about attention use the word emotion in 1992, when I started, and this is in 2016. And so emotion is okay now. We're allowed to talk about emotion when we talk about cognition. So last chunk, last piece of the puzzle is a new line of research. So we did this, and it works really, really well, and we can push the effect around, and we can say, under these conditions, you're distracted, and under these conditions, you're not. And so what we do is we're trying to study people's responses to emotional things. Now, This is Daniel. Is Daniel over there somewhere? Here you are. Participating in one of our experiments, you'll notice, so there's a computer screen, and we're going to flash that N and K thing up on the screen for 1/5 of a second, and then it goes away. And he's got his face in a chin rest because we don't want him to move his eyes around. Sometimes he might be wearing an EEG cap so that we can record his brain responses. This does not seem like a particularly conducive environment to be studying emotion, right? He's pinned down, and you're flashing little pictures of things for a couple milliseconds, right? And so this is why we started to become very dissatisfied with what we call the standard laboratory paradigm. Not just us, lots of people. That it was a really good thing to do for a while, but it really lacks what we call ecological validity. It is not really studying emotion. And so what we did through a series of coincidences, I joined a project started by Tae-Hoon Ri in computer graphics. Also, lesson number 7, get out of your own discipline. All the exciting stuff happens in other schools. But also I stuck out with some people in my school. So Matt Crawford had just bought a VR system. Tae-Hoon was developing computer graphics VR systems. And Chris Maiman started working with us. Chris is over there as our postdoctoral. Eventually we got Marsden funding, and he was our postdoctoral fellow on this project and continues to be my collaborator. And we started with a video game called Richie's Plank Experience. And I'm going to show you how. So you come into this virtual environment. It's a cartoon. There's nothing particularly real about it, but it's a city street, and there's sounds, and it's VR. It feels 3D. You come to an elevator, you get in the elevator, you reach out with your controller, the door closes. Oops, sorry, I didn't mean to surprise you. Elevator goes up 80 stories, and when the door opens, what you see is this. So there is a plank, the elevator opens to the outside, you're 80 stories up, there's a plank that extends out from the building. There's an actual physical plank on the floor in the lab that people are going to walk on. And so we're going to say to them, we just want you to step out onto the plank and walk along it. While they're doing that, we can track all of their movements. We can track their eye movements. We can record all of their physiological responses. So remember, emotion is about physiology. We now have a way to tap into that. So all sorts of great biosensing stuff that we can use. I'm going to skip this one because you're going to believe me. VR is amazing. Here, let me just see if I need to start it. I don't need to start it. On the right, you see what she is seeing.
You will see there's a wooden plank. There is a real wooden plank in front of you on the ground. Please try and step onto the plank and walk to the end in your own time.
Oh my! Oh wow, this is terrifying. I just have to logically tell myself I'm not here.
She's doing really well.
Once you're at the end, I'll tell you. You're about 2 steps away. There you are. You're at the end.
Okay. So this is what we do in our lab now. We don't just do fear. So we have other scenarios that induce feelings of awe. You get to float in space in a galaxy. Others that are disgust. It's a dirty bathroom. And we can induce these really, really powerful emotional states. But now we can insert a cognitive psychology experiment into it. So we can ask people to think, do the things we want to understand in these emotionally taxing virtual environments. So that is what we do. I'm not going to, this is just the steps we go through, but it's going to say exactly the same thing I just told you. We do have a control condition, which is that sometimes the elevator goes halfway up, comes back down, and when they step out, the plank is actually on the city street. It's very disappointing for them usually, but they walk on the plank as well. So the effect isn't just from walking on a plank, it's from walking on a plank that's 80 stories up. Those people down there do not get frightened. I'm just going to show you some of this data. So this is time points as you go along, and we ask people in the control condition how much fear. So when the elevator door opens is in the middle. This is how much fear people have when they're up high. This is how much sweat they do. Control condition, height condition. We have to wipe off the controllers when it's over. This is their heart rate, control condition, height condition, and these are their movements. This is the amount of time it takes them to make that first step. It's up to 5 seconds for the height condition. This is how long it takes them to walk to the end. So we're getting the physiology, we're getting the behavior, and we're getting the subjective fear effect. So that is the environment in which we are now trying to study what happens to attention, what happens to perception, what happens to impulse control under these conditions. I am mindful of time and I want to make a point at the end, so I'll skip data. As a result of being involved in this project, Chris and I co-authored a book on using VR in all sorts of methodologies in behavioral neuroscience research. And it's been a really great opportunity for us. So these are examples of some of our environments. I promised I'd skipping data. So we come to the end. And what we know now that we're allowed to study emotion, is that emotions affect perception. They affect what we pay attention. So they affect what we see and hear. They affect what we pay attention to. They affect what we remember. They affect how we communicate with others. And they affect the decisions that we make. I would argue it's not just that they affect those things. So a lot of people talk about cognition and emotion now. It is cognition. If we think of it as being another type of cognition, now we have the opportunity to think about it as a function of mind, not this separate thing that just is an add-on to it. But it's my mental function like all the other mental functions. And so that's what the work in this field is trying to do right now. I'm going to close with a nod to my colleagues in AI. Marvin Minsky, also before he met Jeffrey Epstein, possibly, I was prescient with this in 1986. This is in the height of the cognitive revolution. Nobody's talking about emotions. And he said, the question is not whether intelligent machines can have any emotions, but whether machines can be intelligent without emotions. Hopefully, I've convinced you humans cannot be intelligent without emotions. So why would we think that AIs could be? We deny that possibility, I think, because we get stuck on the idea of consciousness, that emotion is just the feeling, but it's not, right? There's a lot of stuff going on under the hood that is also part of that. And so a lot of work in affective computing now is trying to build some of that emotion into our current AI models. So that is my final point. I'm turning over to Dave.
For those who've been to inaugural talks before, we're just going to have a little change. I'm going to invite Emeritus Professor Lou Moses up to give a few words to start off with.
Thanks.
Kia koutou. Yeah, I'm Lou Moses. I'm actually an emeritum professor in psychological sciences. I'll just make a handful of points about Gina here. I have only known Gina for a relatively short time. I arrived here in 2019. And so although I've only known her for a very short period of time, I think I've met her many more times than those of you that have known her much longer, with the possible exception of Dave O'Brien sitting over here. In fact, Dave at one point referred to me, I think, as Gina's work husband. And that'll be clear shortly. But I will say at the outset that when I first met Gina in 2019, it seemed to me she was already a professor at that point, and I think she'd been functioning as a professor for many, many years. And so this award of that title at this point is, I think, long overdue for many of us. I came to the School of Psychology as the head of the school in 2019, and it wasn't long before Gina was knocking on my door, begging to be the deputy head of school.
Life lesson number 8.
Yes.
Don't do that. Yeah. I had to learn them all the hard way.
And of course, I had to sign the contract the very same afternoon, and it was really fortuitous because it wasn't long afterwards that the pandemic was upon us, and I was possibly the least qualified person ever to run a school of psychology in New Zealand during a pandemic, because I knew nothing about logistics and procedures and processes really in the university. But Gina did, and she put her heart and soul into that, and co-led the school with me, I would say, really, and really helped get us through that really tough time and coming out of that in great shape. And that exemplifies what Gina does. Whatever you ask her to do, or whatever she takes on, she does it with great talent, great commitment, great emotion, great passion. She brings passion to all of that. Nick mentioned at the start that Gina is sort of something of a Renaissance academic. And
I like that better than well-rounded. Yeah.
That's really true. There's an old joke that some of you will know that trades on national stereotypes, and it goes like this, and it trades on the difference between heaven and hell. And so when you get to heaven, the British greet you at the door, the French do the cooking, the Italians provide the entertainment, and the Germans organise the whole thing. Now, in hell, by way of contrast, the French greet you at the door, the British do the cooking, the Germans provide the entertainment, and the Italians organise the whole thing. Okay. Now, I raised that by
Where are you going with this?
as an analogy, because working with Gina is really like being in heaven, because she, literally, she answers the door very well. She cooks amazingly. She's entertaining, in fact, hilarious if she's had a few glasses of wine. And she's also extremely organised. But then she really is a Renaissance academic, in that she's a talented researcher, elegant experiments. She puts her heart and soul into teaching, mentoring. I know many of the people on that side of the room will attest to what a wonderful mentor she is, and I think I've seen that. She's mentored me in some ways too. And then in terms of, service during deputy head of school, just going way beyond and over and above what one would normally expect in those ways. So she really does. And in terms of that Renaissance metaphor, she's a champion of interdisciplinarity. So we sometimes just we all like interdisciplinary efforts, but Gina lives them through her work in cognitive science and cognitive neuroscience, but also more recently in the fields of meta-science and open science, where she's really looking at science from a much broader perspective about how we can improve the quality of our scientific work. And in fact, at the end of this year, Gina and I are running a conference for the Association of Interdisciplinary Meta-Science and Open Science that brings some of that meta work here to Wellington, and so that should be really great. I'll just finish on one point. a former vice-chancellor once said something, and I suspect that Nick would probably endorse it too, that one of the jobs of a professor is to speak truth to power. And that is something that Gina has always done, and I know she'll continue to do that. She will take on a cause and back it, and she's a bit of a pit bull in that way. She won't let go, but she really believes in social justice. So with that, congratulations, Gina. Thank you.
I just realized, sorry. Oh, I can't make it go. Sorry. My last slide has all my thank yous on it. No? There we go. All right.
Oh, there we go. Okay, so I'm going to paraphrase my thank you speech because, firstly, Gina went way over time, and Lou, I can't compete with Lou's lovely words. So, ko Dave Hapatokinwa, I'm the Dean of Te Pukenga Wai, the fairly new faculty in that psychological sciences finds it, and Gina finds herself of education, health and psychological sciences. So greetings again to everyone here tonight. It's fantastic to see such a large group here, in particular the large contingent, platoon, flotilla, whatever you call it, of past and current students and colleagues from across the university. My paraphrasing. So what's really nice is what I was going to pick up without having seen Gina's talk at all was three key things about what a fantastic collaborator she is, what a fantastic mentor she is, and how fantastic she is at walking the interdisciplinary world between arts, technology, science. So she did it all, and I could reiterate that. And so part of a thank you is thank you for doing and being part of that sort of whatever Renaissance academic that can do that so successfully. So that just paraphrased about 3 or 4 pages of speech. But I had a couple of, and so I'm going to keep it quick because of all the above, but there's 2 things that Gina didn't admit to, which were part of my speech that I do want to repeat here. So Gina didn't talk about all her collaborations, would have gone on for a bit longer, but one of my favourites, which I'll mention now because it's a really nice example of working across disciplines. And it's actually in the top 3 of her publications in terms of citations. You know where I'm going?
Yeah, I do.
Yep. And it was just, luckily I'd stopped being head of school by then because I was a little bit worried. So she published a paper with some colleagues in biological sciences in 2011. It has one of the most memorable titles I've ever encountered in the academic literature. And I quote, "Eye tracking of men's preferences," let's pause, "for waist to hip ratio," pause, "and breast size of women." So one of your top 3 articles.
Yep.
Slightly controversial at the time.
Boob sell.
She said it.
Yep.
So, but thank you, since this is a thank you speech, for your many weird and less so weird collaborations over the years and your use of technology in weird and wonderful ways. You gave lots of examples of your leadership, both through the teaching, research, and Lou spoke to your leadership, formal and informal, in the school and across the discipline. My last anecdote, and then we can go and have some refreshments and harass Gina with many questions and accolades, is that what she didn't point out is that she was so desperate to come to Wellington, her competing job offer was with Hannah's shoe store in Lambton Quay. I kid you not. So she chose to come to the university. The job that we offered her, I actually don't know why I offered it to her. I was sitting there reflecting. We took a chance, but I think, Fuel,
I would
that one
never
worked
get
out.
hired now.
Yeah,
No.
not in Hannah's
Not
anyway.
my junior colleagues, you are all amazing.
So I'm glad you chose Hannah's. Ngā mihi nui koe for your lecture. Thank you for everything that you do. And I think one round of applause. Thank you all.